Hello viewers, we want to solve for x in this nice exponential algebraic expression with a constant term. Okay, how do we deal with this kind of expression? So this is so simple. Stay till the end. Make sure you like, subscribe and turn on notification. If you find this video beneficial, share it to your loved ones. So let's solve for x. Solution. So here we convert this basis to base 3. So we have 3 raised to power x plus 2 multiplied by 3 raised to power 2 into bracket x minus 1 equals to 3 raised to power 3 into bracket 2x minus 3 plus the constant term 5. Then from here we can also simplify the power. That means we have 3 raised to power x plus 2 multiplied by 3 raised to power 2 into bracket x minus 1 equals to 3 raised to power 3 into bracket 2x minus 3 plus the constant term 5. Then from here we can expand this bracket and this bracket. So we have 3 raised to power x plus 2 multiplied by 3 raised to power 2 multiplied by x, 2x, 2 multiplied by minus 1 minus 2 equals to 3 raised to power 3 multiplied by 2x. We have 6x. Then multiply by minus 3, we have minus 9 plus 5. So from here, what we need to do next is to combine these together, the expression at the left hand side. So we have 3 raised to power x plus 2 multiply, that is added with the other exponents of the next term to it. So we have 2x minus 2, everything equals to 3 raised to power 6x minus 9 plus 5. So from here we can simplify the exponent over here. This plus 2, we go with this minus 2, then x plus 2x will be given as 3x, 3 raised to power 3x equals to 3 raised to power 6x minus 9 plus 5. So from here, this expression can be solved algebraically. So we have to use the logarithmic approach to solve for the value of x. Okay, we are going to take the log of this expression. So from here, what we need to do at this stage is to simplify this further again. So this can be given as 3 raised to power 3x. So we try to subtract both sides by this expression at the right hand side, the 3 raised to power 6x minus 9. So by doing that, we arrive at 3 raised to power 3x minus 3 raised to power 6x minus 9, everything equals to 5. So when we do that, when we subtract this from this right hand side, so this gives us 0. So we are left with ordinary 5 at the right hand side. So then from here, what we need to do is to let y, variable y, to be equals to 3 raised to power 3x. Okay, anywhere we see 3 raised to power 3x, we replace it with y. So this expression then becomes, from here we have this. We can simplify this to make it easier to input our x. So here we have 3 raised to power 3x minus this, then becomes, this term becomes 3 raised to power 3x into bracket 2, then over 3 raised to power 9, everything equals to 5. So here now we can substitute our y. So we then have y minus y squared over 3 raised to power 9 equals to 5. So if we multiply this 3 raised to power 9, that means 3 multiply itself 9 times. We are going to get y minus y raised to power 2 over 19,683 equals to 5. So from here we can manipulate this expression. So from here we have to multiply the 19,683 by both sides in order to eliminate the 1 over here. So we have 19,683 multiplied by y minus y squared over 19,683 into bracket equals to 5 multiplied by 19,683. Okay, so here if we multiply through, this will now give us 19,683 y minus, it will get rid of the 1 over here, so we'll be left with y squared equals to, if we multiply it by 5, then that will give us 98,415. Okay, that will be the value for the constant time now. So we can then move the constant term to the left hand side. So we have 19,683y minus y squared minus 98,415, everything equals to 0. We can rearrange this. We have minus y squared plus 19,683y, then minus 98,415 equals to 0. Y squared, okay, minus 19,683y, then plus 98,415 equals to 0. So this led us to a quadratic equation, which will be solved with a quadratic formula. So then we introduce the quadratic formula, which implies y will be equals to minus b plus or minus square root of b squared minus 4ac over 2a. So this is what we are going to use to solve this quadratic expression. So from here, our next step then becomes, if we substitute or introduce the value of a, b, c. So a will be equals to 1 from the equation, then b will be equals to minus 9 683, then minus 9683, then C will be equals to 98415. Okay, so here are the values that we are going to input into the equation. So from here we have y equals to 19683 plus or minus square root of 19683 squared. So over here 19683 squared is minus, okay, it's minus. So we have minus 4 multiplied by 1, which is the A, then multiplied by C, 98415, all over 2 multiplied by A, which is 1, which is equals to 2. So from here, the value of the square root, if we use our calculator, will be given as y will be equals to 91683 plus or minus. So if we resolve this value with our calculator, that means the square root, the expression on this in the square root, we arrive at 9, that is 19663, okay, over 2. Then we can say y can be given as y1 equals to 19683 plus 19663 over 2, or y2 to be given as 19683 minus 19663 over 2. Okay, these are the two possible values of y. So this can be resolved if we press our calculator for the y1 over here. Then we are going to get 19673 to be the value of y1 here. Then for y2, if we press our calculator as well, we are going to arrive at 10. Okay, these are the two possible values of y, but mind you, the value of y, that is y1, is too large, so it will not be considered because it will be invalid to be taken as the value of y. So it is too large, okay, invalid. So this will be invalid, this value will be invalid. So we are not going to make use of this value as our value of y because of how large it is. Okay, then here we can now go ahead to solve for the value of y. So we can recall that since our 3 raised to power 3x equals to y, so we can then take the log of this now. So here will be given as 3x equals to log of y in base 3. Okay, so from here we can divide both sides by 3. So divide by 3, divide by 3, this cancel out this, so we are left with x to be equals to log of y base 3, okay, over 3. So this is what we are going to use to solve for the value of x. So we can now input the value of x, that is the valid 1, okay, not the invalid one, the large one, not the large one, but the second one, which is the y2. So if we input that value over here, we have x equals to log 10 base 3 over 3. Okay, so from here, if we resolve this using our calculator, the numerator, we are going to arrive at the approximate value of x to be given as 2.0959 over 3. So if we divide this, we also arrive at x is approximate to 0.6986 as our value of x. Okay, so there is no solution for the second value of x. So we are only going to have one value of x, which is x equals to approximate value of 0.6986. So because the first value of y to get the second value of x is too large, so this exceeds practical bound in algebra. So that is, it yields one practical solution.